Now that we've finished the questions, let's move on to the next topic, which is the cosine function. This is very similar to the sine function, except it is translated through the horizontal axis. Yeah, so it starts with 1 at like cos 0 would be 1, and then you see the same pattern as you saw with the sine function. And then it's gonna have zeros at 90 degrees and 270 degrees, and we have two maximums and one minimum, and the minimum occurs at 180 degrees. So as you saw, the sine function looks somewhat like this, the thing that I'm tracing right now. This is how the sine function looks. So if we move it this side, this is what we get. So it's essentially a translation of by the vector minus 90, 0. Okay, now I'm going to show you some of my own notes. I was supposed to draw the function, but like I was too lazy, so we'll just ignore that. The cos x is a function as it passes the vertical test. A vertical, yeah, also ignore the spelling. So a vertical test is a test for um, a relation. So if it passes the vertical test, it means it's a function. Cos x is 0 when x is an odd multiple of 90. For example, 90 and 270, as we can see here. And then cos x is either 1 or minus 1 when x is an even multiple of 90. At 0, we have a maximum. At 360, we have a maximum. And at 180, we have a minimum. And then cos 0 and cos 60, yeah, that's option. Then cos x is a function. The cos function is a periodic function because it repeats itself over and over again. So if you continue to draw this, you're going to have the same exact graph over here too, starting with 360 and ending at 720. Okay, the period of a periodic function is defined as the length of one repetition or cycle. We've already gone over it, so I'm just gonna skip this part. And then it's very similar to the sine x graph. So even here, cos 2x has a period of 360 by 2, which is 180 degrees. So to find the period, we have to divide 360 by b, which is basically cos bx. And then the amplitude is defined as the distance between a maximum point and the principal axis. So the amplitude for this would be 1 because this is the principal axis and the maximum occurs at 1. So the amplitude here also is 1 because -1, 0. Anyways, let's move on. Then the basic cosine function has an amplitude of 1. As you can see in the graph, it has an amplitude of 1. I'm just gonna brush past this really quickly because we've already done something very similar with sin x. So this is the graph of cos x, and this would be 2 cos x because the amplitude will double because we have the value of a as 2, and then it's a stretch of the graph of y equals to cos x, and it is stretched from the x-axis with a stretch factor of 2. And the amplitude of y equals to 2 cos x is 2, and the period remains the same, which is 360 degrees. Similarly, the graph of y equals to 3 cos x is a stretch of the graph y equals to cos x from the x-axis with a stretch factor of 3. Amplitude is 3, and then the period remains the same. Okay, now that we've covered what y equals to cos x does, let's look at cos bx. So as we discussed previously, the period is gonna be 360 by b. So if we have cos 2x, then the period would be 180 degrees. So it keeps repeating. For every 180 degrees, you're gonna have one cycle. The graph of y equals to 2 cos x has been stretched from the y-axis with a stretch factor of 1 by 2. So this is the y-axis, and it has been stretched by a factor of 1 by 2. And the amplitude of this remains the same, but the period would become 180 degrees. And similarly, the graph of y equals to cos x by 2 has a stretch factor of 2 from the x-axis. And the amplitude is 1 and the period is 360 by 1 by 2. So it's 4 pi or 720 degrees. So as you can see, we complete a full cycle between 0 and 720 degrees because the period is 720 degrees. And finally, we're going to look at translation. We have cos x plus c, then it's going to translate by the vector 0, c. So this is y equals to cos x, and then we shift that 1 unit up. So this is what we get. So this is the explanation. It's very similar to the sine x one. So the graph of y equals to cos x plus 1 is a translation of the graph y equals to cos x. It has been translated by the vector 0, 1, and the amplitude of y equals to cos x is plus 1. Plus 1 is 1, and the period is 360 degrees. The graph of y equals to cos x minus 1 is the translation of the graph y equals to cos x by the vector 0, minus 1. The amplitude of the graph of y equals to cos x minus 1 is 1, and the period is 360 degrees. So when you translate something, the amplitude and the period does not change. So this is the conclusion. Very similar to the sine x one. So we have y equals to cos a cos bx plus c. The a factor would affect the amplitude, and a would be the amplitude of the graph. B affects the period, and the period would become 360 divided by b, which is in degrees, or 2 pi by b in radians. And then c affects the translation, a vertical translation that too, and the translation would be 0, c. So that's all you need to know about the cosine function. So now let's solve a few questions. Let's look at the first question. Without using technology, sketch the graph of y equals to 3 cos 2x for the domain between 2 pi and 0. Okay, I will try my best, but as we have clearly established, I'm not a good drawer. So I will just try my best. Okay, so the amplitude would be 3. So let's say this is 3, this is minus 3, and the period would be 180 degrees. So this would be 360, and this would be 180. Okay, so we start with 3, and we go down, and then go up. That's terrible. Okay, we got to do that again. Okay. So they told us to do this without technology, but we definitely need to. So I'll just type in the thing here. So this is what it's supposed to look like. It looks somewhat similar, but this is how you're supposed to draw it. So when you're drawing it on paper, it's easier because you can plot the points, but then on the screen you can't really do that properly. So yeah. Now let's look at the next question. We have to find the cosine function for the following graph. Let's use the concepts we have learned to solve this question. Alright, so we'll start with the first one. Over here, let me use a different color. Okay. We can see that the principal axis is clearly y equals to 0, my bad. It's y equals to 0 because above this line and below this line, we have the same amplitude. So the value of a would be 2. Alright, so now that we've established that, we can clearly see that there is no translation. There's no vertical translation or horizontal translations. Although you don't need to know the horizontal translation, it's fine. You don't have to know that. Anyways, we can see that it completes one, two. It completes two cycles from 0 to 2 pi. So the period is 180 degrees, and we know that the period is 2 pi by b. Let's just write pi instead of 180 degrees. So this would be pi. This would mean that b is 2. Therefore, of y equals to the amplitude into cos 2x. This is our answer. Let's move to the next question. Okay. This has vertical translation. If you want to find the amplitude, what we can do is subtract the maximum minus minimum divided by 2. So that will be 3 minus 1 divided by 2. No, we're not finding, yeah, okay, never mind. This will be 2 by 2, which is 1. So the amplitude would be 1. And the translation C would be 2, because this is the principal axis, right? And then we're moving up by 2 units. So therefore C would be 2. And now we have to, wait, let me clear this. Now we have to find the period. We can see that it completes the cycle between 0 and 4 pi. So it takes 4 pi units to finish one full cycle. So therefore, 4 pi equals to 2 pi by b. b is therefore 1 by 2. So our final answer would be y equals to a cos bx plus c. Now let's substitute the values in. This would be 1 cos 1 divided by 2x plus 2. This is our final answer. Let's verify the answer. This is exactly what we got. So I hope this concept is clear. Try to solve as many questions as you can to familiarize yourself with the type of questions that might come.